Yeah, we can do a little test. I prepared a plank, so to speak, that has a long hole drilled into it. I think roughly halfway. So this is the usual when you're making a safe lock tool or whatever. It has a very thin section, so that presents a problem in heat treating. When you're heating it, it heats very quickly. And also when you remove the heat and quench, you basically have 1 second to quench it, because otherwise the heat just goes away. It's so thin, it doesn't retain the heat. And also in some tools you have some sort of millings here or cutouts, or it's kind of offset, it's not round like this. So it presents a problem in how do you heat it so it's evenly heated, and how do you dunk it into the water evenly, or how do you get it to cool evenly because it's so offset shapes. And that's where a drill press is very handy. So we can do this on a drill press. The best way of heating small parts and evenly, and you can actually control how long of a hardening you're going to do to it. Like if you're, for example, making a cutting tool that you don't have, like one lip cutter or special shaped milling bit or whatever, you always want the shank to be not hard, and you would just want to harden the end of it. So this is the perfect way to harden it in that way also. So let's see if we don't have a range. Of course. Let's raise the table. I think that's enough. Yeah, it goes in. That's good. So, and the only thing here, I'm holding the flame way away from the part, and you can already see it's starting to take color because it's so thin. So you have to be really patient with the flame, and heat goes up in here. So if I hit the end, it basically draws the color up. And I'm just watching the color, so it stays quite the same the whole length that I want to harden. Slowly, always keep the flame in contact with it and try to keep the whole thing constant temperature, and slowly bring the temperature up, because it's always also bad if you heat it too fast. The metal doesn't like it, and you basically have to have some base temperature in the metal. So heating evenly the whole length, it's tricky with the part that is very thin. So we are getting to the temperature in the end. And this is also good because it's rotating. It's automatically working for us in the quenching, so we don't have to swirl it around in the water. Especially if you have a cutout in the part, like a milling cutter, it basically breaks the water surface completely. Still a little hot for fingers. But now we have a hardened piece. I think we have, yeah, we can actually see the point where the water level was. So this is usually not good. You want to go the whole length into the water, but because limitations, it's a good example. We can test with the file from both sides if there's a difference. This should be hard. This might be harder, not quite hard, and this is still soft because it was not even heated. So we can test it. So that's the soft end, bites easily. That's the almost heated, still bites, doesn't feel as soft. And that's the heated end. Doesn't almost takes the color away. But now, if we want to make this not brittle, we have to temper it. Do we have a sandpaper piece here or something? Get rid of the color.
The impressioning room has sandpaper. Is that your toolbox?
So, I'll take the chalk. Look from here. If we pretend that we are making a tool and we want the 50 Rockwell hardness, it requires roughly, let's say we go with the 400 or 450. So if we go to the chart, we can see that 427 would be dark gray. It's just past, once the blues go away, that's the temperature we want. We have to get rid of the scale that is the burned metal or oxidized metal to get to the nice silver bare metal, so we can actually see the colors coming up when we heat it. That's good. Put it on the press. And again, the rotating part is very nice for even heating. And now, especially when you're tempering, you have to be really careful with the flame and temp, because we just want to heat it enough. And if you notice that you're about to go past the proper temperature, you can just dunk it into the water to stop the tempering, because the metal, if it has some larger section right next to the part that is thin, it retains a lot of heat and it might draw the heat back to the thin part and it tempers too much. That's a typical problem when you're making a cutting tool, because the cutting tool's edge is usually very thin while the shank is very thick.